Hello everyone, it's lecture 10 to solve polynomial equation of the fourth degree by Ferrari method. Okay, so let's start with steps of Ferrari's method. Okay, now let me write that step 1. Okay, if we have equation of the fourth degree like that, a naught x power 4 plus a1 cube of x plus a2 x squared plus a1x plus, here we have 3, a4 equal to 0. Okay, so the first step is to transform this equation to make the coefficient of x power 4 equal to 1. So here we just divide by a naught. Okay, so we obtain x power 4 plus a cube x plus b x squared plus cx plus d equal to 0. Okay, so this is the step 1 of Ferrari's method. Okay, next step, step 2, okay, is just to add the value of here m x plus n square to both sides of equation. Okay, so let's do that. So we have here x power 4 plus a cubed x plus b x squared plus cx plus d here plus mx plus n squared will be equal to mx plus n squared. Okay, so just let me expand this bracket. So we obtain here x power 4 plus a cubed x plus b squared x squared plus cx plus d plus, here we find m squared x squared plus 2mn x plus n squared will be equal to mx plus n. Okay, so let's move to step 3 is to complete the square of the function on left hand side. So any equation of fourth degree can be complete to the square like that. So we have here just here x power 4 plus a cube x and coefficients of the same power of x together. So here we have 3 plus here m squared x squared plus here we have c plus 2mn x, and here we have plus d plus n squared. Okay, this will be equal to here x squared plus half of a x plus I square equal to mx plus n squared. So there is we have here the completion of the square of any fourth degree polynomial equation, just like that. X squared plus half ax plus I whole square. Okay, so here from here just this bracket, just right like that. Here we have x squared plus half x plus I z square equal to mx plus n squared. So x squared plus x plus I will be equal to plus or minus mx plus n. Okay, just keep that. Okay, and here step 4, just to compare the coefficients of x power n and both sides. Okay, so here we have from this expansion we have here x power 4 plus a cube x plus b plus m squared x squared plus c plus 2mn, okay, x plus d plus n squared will be equal to, here we have x power 4 plus a squared by 4 x squared plus I squared plus a cube x here plus ai x plus 2i x squared. Okay, so here we obtain that. Okay, here we have 1 here about cube of x a. Okay, so we will compare from x squared, so we have here p plus m squared equal to, here we have a square, okay, and 2i. Okay, so from here m squared equal to 2i minus p plus a squared by 4, and let's name this one. Okay, again compare the coefficient of x, so we have here c plus 2mn equal to, here we have ai, so here 2mn will be equal to ai minus c, okay, and this 2. Okay, again compare the free term, we have here d plus n squared equal to I squared, so here we have n squared equal to I squared minus d, and here is the third one. Okay, just we have to here we have to square both sides of number 2. Okay, so 2 square will be like 4, m square n square will be equal to ai minus c square. Okay, and here from 1 and 3 we can substitute with m square and n square. So here we obtain the most important equation here. Okay, we obtain that ai minus c square will be equal to 4 and 2. Here we have I square minus d from the third one. Okay, and 2 m square which equal to 2i here minus b plus a square by 4. Okay, and here is the most important one of solving. Here I have third degree equation of I. Okay, by solving for I and obtain I can back substitute to get m from here. Okay, and n from here, and the relation between n and m from here. Okay, and by using I, okay, m, n, okay, I can substitute in this equation, okay, to get the roots of here the base equation. Okay, I hope these steps are clear, and let's verify it by an example. Okay, just the first example asks to solve x power 4 here minus 10x squared minus 20x here minus 60 equal to 0. Okay, so we will use Ferrari's method to solve this equation. Okay, let's start with step 1. So step 1 is to transform this equation to another equation which a node equal to 1, but we have here a node equal to 1. So step 1, okay, is performed. Okay, here step 2, we don't have to repeat the step 2 and step 3. Okay, just we will go to this important equation of I. So here step 2 and step 3 will performed by this whole equation. Okay, so we have here a equal to 0, b equal to negative 10, c equal to negative 20, here d equal to negative 60. Okay, so here we have to write this equation here. Here we have ai minus c square equal to 4 and 2 I square minus d into 2I minus b plus a squared 4. So just substitute with values of a, b, c, and d. So we have here a equal to 0. So we have here c squared. Here 20 squared will be equal to 4 into I squared minus d. We have here d equal to negative 16. So we have here plus 16 into 2I. Here we have b equal to negative 10. So we have here plus 10 and a here equal to 0. Okay. So let's just perform this multiplication of bracket. So we have here 20 squared equal to 4 into here we have 2 cube of x plus 10 x squared, and here we have plus 32I plus 160. Okay, so just add the same coefficient of I to obtain that we have cube x plus 5x squared plus 16i here plus 30 equal to 0. Okay, so here just to solve for I, okay, and I here will be equal to negative 3. Okay, there are another two imaginary roots will be eliminated. Okay, so we have here I equal to negative 3. Just back to this equation to get m squared equal to 2I negative 6, and here minus b plus 10, and a here we have a square equal to 0. So m square equal to 4. Here we have m equal to plus or minus 2. Okay, again for n, so n square equal to I square minus d. So we have here I square 9, 9 here negative d here plus 16. So we have here 25 and equal to plus or minus 5. Okay, we can stop here. We must obtain the relation between m and n. So here from the second one here we can obtain that m into n equal to half of ai minus c. So m into n will be equal to, here we have 10. Okay, so here we have two cases, m into n equal to 10. So we have here m into 2 and n into equal to 5, or m equal to negative 2, n equal to negative 5. Okay, after that we have here I, okay, n and m. Okay, so we obtain we have to perform this equation. This from the completion of square. So to get the roots of this equation, just we will perform this step of just here, clear. We have here for m equal to 2, n equal to 5, and I equal to -3. We have here x squared here plus half of ax, a here equal to 0, so here we have plus I, so we have here, okay, equal to, the first case is m equal to 2 and n equal to 5, so we have here 2x plus 5, okay, so just here we have x squared minus 2x, and here minus 8 equal to 0. Here we have x minus 4 and 2, x plus 2. So the first two roots is x equal to 4 and x equal to -2. Okay, and again to obtain the second roots of the equation, for m equal to -2, n equal to -5, and I equal to -3. So we have here x squared minus 3 will be equal to here -2x here minus 5. So we have here x squared plus 2x, and here plus 2 equal to 0. Just we will obtain x3 and x4 equal to -2 plus or minus here square root of, here we have 4 minus 8, okay, by 2. So we have here x3, x4 equal to 1 plus or minus I, okay, and there are 4 roots of this equation by using Ferrari's. For example, on Ferrari's method is to solve x power 4. Here we have plus 4x 4 cubed x minus 6x squared plus 20x here plus 8 equal to 0. Okay, so here step 1 not needed, as we have here a1 equal to a node equal to 1. Okay, and step 2, 3, 4 will be performed with this function. Okay, so just we have here a equal to 4, b equal to -6, c equal to 20, and d equal to 8. Okay, just from start from this equation, so we have here ai minus c squared equal to 4 I squared minus b into 2i minus b plus quarter of a squared. Okay, just substitute with these values. So we have here 4i minus 20 squared will be equal to 4. Here we have I squared minus 8 into 2i plus 6. Here plus we have here 4. Okay, so here we just 4i minus 20 square equal to 4 I square minus 8 yes into 2i plus 10. Okay, by performing this multiplication we will obtain cube I here plus 3i square plus 12i minus 90 equal to 0. Okay, and by solving this third degree equation we will obtain that I equal to 3, and let me write this note for the roots of this equation. Okay, here the roots can be a, b, and c. Okay, just we can substitute with a. Okay, we can substitute with b, we can substitute with c. Okay, and for the result value of m n, and by substitute with I, m, and n in this equation and obtain our root, we must make sure that these roots are the roots of this equation. Okay, so if we have here 3 like that, 3, 4, and negative 5. Okay, we must perform our steps, okay, of m, n, and then with I, m, n to obtain x1, x2 to x4. Okay, and we must make sure that these roots are the roots of this equation. Okay, so we have here 3, I equal to 3. So just here we will obtain m squared equal to 2i minus b plus quarter of I squared. So m squared equal to, here we have 6 plus 6, here plus 4. So we have here 16. M equal to plus or minus 4. Okay, for the second equation, n squared equal to I squared minus d. This equal to, we have here 9 minus d, here d equal to 8, so we have here 1. Now n equal to plus or minus 1, and don't forget the last one, the relation between m and n. So we have here m into n equal to, here ai minus c. So we have here 1/2 into a equal to 4 into I minus c equal to negative, c equal to 20. So we have here 12, and here we have minus 20. So we have here negative 4. Okay. So for this value of m into n, so here we have m into n equal to negative 4. We have two cases here. M if m equal to 4, then n equal to negative 1, and here if m equal to negative 4, n will be equal to 1. Okay, so here we have I, m, and n. Okay, so just here. Okay, we have here from this equation we have here x squared plus 2x here plus I equal to plus or minus mx plus n. Okay, so this equation for the first two rows, we have here m equal to 4, n equal to negative 1, and I equal to 3. Okay, so we have here x squared here, half of a equal to 2, 2x here plus 3 equal to the first one is 4x minus 1. So we have here x squared minus 2x plus 4 equal to 0. So here x1 and x2 equal to 2 plus or minus square root of 4 here minus 16 by 2. So we have here x1, x2 will be equal to 1 plus or minus square root of 3i. Okay, and here for the second two roots, m equal to negative 4, n equal to 1, here I equal to 3. So we have here x squared plus 2x plus 3 equal to here negative 4x plus 1. So here x squared plus 6x here plus 2 equal to 0, and here x3 x4 equal to negative 3 plus or minus square root of 7. Okay, so here the last two roots of this equation. Okay, let's move to another one. Here we have to solve. Here we have to solve x power 4 plus 2x cube 2 cube of x minus 7x squared minus 8x here plus 12 equal to 0. Okay, so just here we have a node equal to 1, so no need for, so we have here a equal to 2, here b equal to -7, c equal to -8, and d equal to 12. Okay, so just start from this equation. We have here a I minus c square equal to 4 I square minus b into 2I minus b plus quarter of a square. Okay, just substitute with a, b, c, and d. So we have here 2I plus 8 square equal to 4 into I square minus 12 into 2I here plus 7 and here plus 1. Okay, just by perform this multiplication we will obtain here 4I square plus 32I plus 64 equal to, here we have 8 cube x here plus 32I square minus 96I minus 48 into 8. Okay, so we have here 8I square plus, sorry, 8 cube of I plus 28I square minus 128I, and here the free term is 448 equal to 0. Okay, as you said before, I we can obtain from here I for 3 real number. Okay, we have here I equal to 4, -4, and negative have 7. Okay, so what will we do here? We just enlarge our nested. Okay, start with I equal to 4. Okay, and then obtain m, and then substitute to get x1 to x4, and here we must, as you said before, make sure this roots are the roots of this equation. Okay, so we just start here, take I equal to 4, so here m square equal to 2I minus e plus a square by 2, so we have here 8 plus 8 equal to 16, m here equal to plus or minus 4, here n square equal to I square minus d. So we have here I square 16 minus d equal to 4, and here equal to plus or minus 2. Okay, the relation between this m into n from this equation, from the second one, m into n equal to half of ai minus c. So we have here half of 2 into 4 minus c. So here plus 8. We have here into 8. So we have here 8. So 4 I equal to 4 m into n equal to 8. So here we have m equal to negative 4, n equal to negative 2, or m n equal to 4 and n equal to 2. Okay, so just clear to get our roots. Okay, so we have here a sorry we have here x square plus ax plus I equal to plus or minus m and mx plus n. Okay, mx plus n. So here for the first two roots, here we have I equal to 4, m equal to negative 4, and n equal to negative 2. We have here x square plus x here plus I 4 equal to 4x here minus 2. Okay, so x square plus 5x here plus 6 equal to 0. We can factorize that into x plus 1, and here x plus, here we have x plus 2 and x plus 3. So here x equal to x1 equal to negative 2, x2 equal to negative 3. Okay, and for the second two roots, we have x square plus x plus 4 equal to 4x plus 2. So we have here x square here minus 3x here plus 2 equal to 0, x minus 1, and x here minus 2. So we have here x3 equal to 1, x4 equal to 2. Okay, we here just don't stop here. We must make sure these roots are the roots of this equation, okay? As we act here with I equal to 4, so just substitute with 1. We have here 1 plus 2 minus 7 minus 10 plus 12 equal to, here we have 3, so we have here 15 minus 15 equal to 0. So here we just make sure these roots are the roots of this equation. So no need for negative 4 and negative 7 by 2 of the values of I. Okay, I hope Ferrari's method is simple. Okay, just follow these steps. Okay, which perform which performed by this equation on the left to obtain I, M, and N. Okay, and here method to solve the equation of the fourth degree. Okay, just we will repeat our steps quickly. So step 1 is to make sure a node equal to 1, the coefficient of x power 4. Okay, if doesn't, just divide by a node to obtain this x power 4 plus a cube x plus bx squared plus cx plus d equal to 0. Okay, step 2, we just add mx plus n squared to both sides of this equation. Okay, and perform that. Step 3, we just complete the square of the resultant left hand side after adding the bracket square. Okay, so here the left hand side equal to x squared plus half ax plus I squared, which equal to the right hand side of mx plus n squared, just to obtain x squared plus half of ax plus I will be equal to plus or minus mx plus n. Okay, so here plus or minus, as we did in previous equations, plus or minus to obtain here two values or two expression. For obtain, for the first one x1 x2, and here for the last one x3 and x4 for the different expression here. Okay, so here step 4, we just compare the coefficient of x power n in both sides from the left hand side, and this expansion of this bracket, just we obtain this m squared equal to 2i minus b plus quarter of a square, n squared equal to I squared minus d, and here 2mn equal to ai minus c. Okay, we just call this 1, 2, and 3. Okay, and from square of the second equation we can and by substitute with m square and n square in the last one, sorry, we just replace this. Okay, so by square the third equation and substitute with n square and m square, we just obtain this equation ai minus c square, okay, will be equal to 4 into I square minus d into 2i minus b plus a square by 4, and we said just this is the important equation, third degree in I, and for a, b, c, and d are integer number, I will be real number. Okay, so we will just solve this third degree equation for I. Okay, so we have here value of I and then back substitute to get m from here, and here back substitute to get n from here, and we have now I, m, and n. Okay, just substitute in this quadratic equation for the values of m, n, and I, and don't forget the relation between m and n. Okay, just substitute here in this quadratic equation to obtain for first values of m, n, we get x1, x2, and here for second values of m, n, we just obtain x3 and x4. Okay, and there is important note here, as we said, if I from here we obtain three different real values of I, just substitute with these three values, start from the first value, the next value, and third value, and just we here enlarge our nested. So we have here values of I, values of m and n to just obtain x1, x2, x3, x4, and again just we will make sure for this value of I is this root, for example x1 will verify this equation. Okay, so I here is the value we need. Okay, I hope that is clear. Okay, and I hope these steps are well verified by our example in this lecture. Thank you for watching.